which I find to be the most appealing for visualizing general relativity. The Earth, because it is very massive, deforms spacetime, giving it a curvature. For us, the curvature of spacetime appears as an endless contraction of the grid. In technical terms, we say that the volume contained between geodesics shrinks over time. Thus, if we drop the apple with no initial velocity, as no force acts upon it, it will remain motionless relative to the grid, but as the grid contracts, the apple will fall. With this image of relativity, it is also easy to see that the surface of the planet is constantly accelerating upwards, because it is always going against the natural movement of the grid. Finally, if we throw an object sideways with an initial velocity, no force is applied on it, and it will therefore continue in a straight line within the grid. But as the grid contracts, the object is constantly pulled back towards the Earth. That's exactly how the Moon orbits the Earth, and the Earth orbits the Sun. In which we live. Finally, the most important issue with this representation is the fact that our diagram completely ignores the time dimension. Spacetime is an object with 4 dimensions, 3 dimensions of space, but also 1 dimension of time, which can equally bend and curve. Faithfully rendering a 4-dimensional geometry is strictly impossible, and we therefore have to find a trick. A first idea would be to add small clocks to our diagram at each point of the grid. In this way, the space grid becomes a space-time grid, and we understand that time can flow differently depending on where we are, in which we live. Finally, the most important